Assalamualaikum and hi everyone. My name is Muhammad Aidil Hakim Ibn Sapian. My matrix number is 01DEE24F1056. And today I will presenting generic skill practical work 3 for subject semiconductor device. The topic of this generic skill is bipolar junction transistor or BJT. A bipolar junction transistor or BJT is a type of semiconductor device used in electronic circuits for amplifications and switchings. It consists of three terminals, which is base, collector and emitter. BJT are crucial components in analog and digital circuits and are widely used in amplifiers, oscillators and switching devices. Objective of this generic skill is to investigate the BJT terminals, BJT types, and the materials used in BJT. This helps in understanding the structure, function, and characteristics of BJT in electronic circuits application. BJT terminals and functions. A BJT has three terminals. The number one is base. The control terminals that regulates the current between the collector and emitter. The second is collector, the terminal where the current enters the transistor for NPN or PNP. The last one is emitter, the terminal through which current exits the transistor for NPN or PNP. The functions of these three terminals is the base controls the transistor operation. The emitter emits charge carriers, electrons or holes. And the last one is the collector collects the charge carriers from emitter. In an NPN transistor, current flows from collector to emitter, and a small current into the base allows a larger current to flow from collector to emitter. In a PNP transistor, current flows from emitter to collector. A small current leaving the base allows to a larger current to flow from emitter to collector. BJT types. There are two main BJT types of BJTs. The first one is NPN transistor and the second one is PNP transistor. For the NPN transistor is made of two N-type materials separated by a P-type base. For PNP transistor is made of two P-type materials separated by an N-type base. For the differences between these two main types of BJTs, the first one is in NPN, current flows from collector to emitter, while in PNP it flows from emitter to collector. And the next is NPN requires a positive voltage at the base, while PNP requires a negative voltage at the base. BJT materials. BJT are made using semiconductor materials such as silicon and germanium. However, silicon is more commonly used in modern BJT due to its thermal stability and electrical properties. This is because silicon can withstand higher temperature. Next, it has a higher breakdown voltage and lower leakage current. And lastly, silicon is cheaper and more abundant than germanium. For the conclusion of this generic skill, first, BJTs have three key terminals, which is base, collector and emitter, each with specific roles in current control. Second is there are two types of BJT, NPN and PNP, with different current flow and biasing requirements. Lastly, silicon is the preferred material for BJT manufacturing due to its superior properties. Understanding BJT terminals, BJT types, and BJT materials is essential for designing and analyzing electronic circuits, especially in amplification and switching applications. First, reverse the multimeter probes. Then plug the probe at the negative COM output of the multimeter. And plug the black probe at the positive output of the multimeter and select 10 ohm. Next, do the 0 ohm adjustment. After that, touch the red probe to the first terminal and the black probe to the second terminal. The scale is infinity ohm. Then, move the black probe to the third terminal. The scale is infinity ohm. Then, move the red probe to the second terminal and the black probe to the third terminal. The scale is 60 ohm. After that, move the black probe to the first terminal. The scale is 60 ohm. And then, move the red probe to the third terminal and the black probe to the first terminal. The scale is infinity ohm. After that, move the black probe to the second terminal. The scale is infinity ohm. So, this is the result. First, change the ohm range to a higher range 10k ohm. Next, put the negative probe to base and positive probe at terminal 1. The scale is low. And then, put positive probe at terminal 3. The scale is infinity. So, this is the result. First, change the ohm range to 10 ohm. Put the negative probe at base and positive probe at terminal 1. The scale is infinity. Then, put positive probe at terminal 3. The scale is infinity. Next, move the positive probe to base and negative probe to terminal 3. The scale is low. Lastly, move the negative probe to terminal 1. The scale still low. So, this is NPN transistor.